remember ChatGPT? Okay, I don't know who's going to win this, but a lot of people are chasing it. Amazon, Facebook has their Llama model, and Apple is doing some stuff. Google, of course, with Bard and their Palm 2 model. There's a bunch of stuff going on. So what I'm talking about will apply to any large language model, even though we're going to focus on ChatGPT. Okay. So first of all, I'm going to give you guys a little bit of a background in terms of machine learning. Not much, but here's what I want you to understand about all of this. How in the world can a machine understand language? How in the world does that happen? How can a machine do those things that we ask it to do? For those of you who've used ChatGPT, how does it do that? And so that's why I want to give you a sense of how it was trained, so you get a sense of large language models in general. So machines learn by example. That's what machines want from you. Machines say, just give me examples of your world. Just tell me about your world. I don't live in your world, but if you can give me examples of your world, I can learn it. I can learn it. You guys, a neural network can learn anything with enough data and enough time, if it doesn't require a lot of reasoning. And even now, with the generative models, it's even getting better with reasoning. But I want you to get, first of all, machines learn by examples. So the way these models are trained, first of all, let me orient you. If you wanted to teach a machine how to differentiate between a positive and negative movie review, maybe that's your task. Your machine, I want you to know what a positive review is versus a negative review. I can't tell you what it is. I don't know. I mean, I know it when I see it, when I read it, but I don't know how to describe it to you, what a positive or negative review is. Okay, so you need to help me out. You just have to learn it. I can't code it. I can't tell you it. You just have to learn it. And the machine says, okay, I'm happy to do that if you give me examples. So you're going to collect a bunch of examples of movie reviews. And you say, okay, machine, this one's positive, this one's negative, negative, and positive. I've read through them. I know it because I've read them, but I can't tell you why I know they're positive and negative. I mean, that would always be true. So you're going to have to learn it. And so the machine learns by you just giving it as many examples as you can, as many examples as you can. Okay. And importantly, you give it a label. That's what we call a label. Okay. Just like your professor scores your test and gives you feedback. And so you can see, oh, now I see where I got that calculus problem wrong or right or whatever. I need feedback. And that's how the machine learns. You give me feedback. Just tell me if I'm right or wrong. And we do that with labeled data. And sitting in between your examples is some algorithm. It has nothing to do with you. Machine learning is not you. Okay. Some algorithm is going to sit between your examples and learn whatever you asked it to do. You have to come up with just a brilliant question and get a bunch of data or examples of the world and let the machine learn it. It's just, like I said, an incredible time if you can get your hands on data and ask great questions. So this right here, we call supervised learning, because we're supervising the machine's learning like your professor or your teacher might supervise your learning. Tell me when I'm right. Tell me when I'm wrong. Feedback, knowledge of results. Tell me how I did. Okay, same thing. You want to know about a cat and a dog? Give it as many cats and dogs as you can. I can't tell you, machine, what a dog is. I know it when I see it. I can't tell you. I mean, I know it, but I can't tell. I've never seen every dog, but I know it when I see it. So all I can do is give you as many examples as I can and give you labels. That's all I can do. But the problem, you guys, is supervised learning. It's expensive and time consuming to get a bunch of labeled data. If I wanted to get 1 million images of cats and dogs, man, that would be hard because I have to get them and I have to pay someone to label them. And that's just, it's hard. But I do know that machines do better when they have a lot of data. So I'm torn. Do I give it accuracy by getting data and labeling it? Because I know that's going to be exactly what a dog is. Or do I not label it? That's what we call unsupervised learning. What if I don't label it? Then I can give it as many cats and dogs as I can. I'll go get you 1 million cats and dogs right now if I don't have to label them. I'll just go scrape and get everything I can find on the internet and give it to you. And then we hope that the machine can learn patterns on its own. Maybe by giving it so many examples, it can start to learn what a dog is and what a cat is. That's our hope. Okay, so I'm going to come back to this supervised problem. Supervised tells the machine, this is what humans want. This is aligned with what humans would expect. That's supervised learning. Remember, machine doesn't live in our world, doesn't even know what a human is. But if we can supervise, give it labels, it tells this is what humans would expect. Okay, but that's hard to do. So unsupervised learning, we can give it a lot of data though. So we're torn. We're in between those two. So we're gonna come back to this, but I do want you to know what supervised learning is. It means we have an answer key. Unsupervised learning is I've given you data, but I haven't told you what it is.